Well, I was very happy as a professor of theoretical physics, and then I had a kid. All of a sudden, it mattered to me that the world was sort of burning down around. A company that sequesters carbon in the ocean is making gold, right? It's a carbon offset. It's an asset that they can sell. Problem
Yes.
is that gold is invisible.
Yeah.
You look at the water, you can't see it. And so our job is to make that gold visible. Imagine you've got a Marvel superhero and they have some amazing thing. They can see through walls, but maybe they can't hear anything. You get one sense superhero and they can sense amazing things. But you get a team of superheroes together and they have a much richer picture of everything that's going on. They can see what's on the other side of the wall. They can also feel what's on the other side of the wall and hear what's on the other side of the wall. And that kind of having lots of superpowers is more than just having one. And that's what sensor fusion is all. One sentence of hope. Oh, I like that. And I walk into the lab every day and it gives me hope just seeing what these folks are doing. It's so much fun.
You're listening to Bite Size Climate Tech, Season 4. Let's dive in.
Time to make climate cool again.
Today we're going to talk about a really cool concept. It's sensor fusion. Hi, Alan.
Hi, Lydia.
Nice to meet you. I'm so happy for you to join us today because this will be our first episode of Season 4. So Bite Size Climate Tech is a 5 minutes podcast. I talk to scientists and engineers exactly like yourself. You're a visionary physicist. You used to be a professor in university and teaching physics, and now
1.3 billion years ago, in a distant galaxy.
And now you a climate tech innovator who founded this company, Aquatic, to develop scalable, low-power ocean sensing technologies that enable real-time monitoring of seawater chemistry for enhanced carbon dioxide removal. Am I correct?
That's exactly it. Yeah. Thanks so much for having me on. This is going to be really fun.
So today we're going to talk about a really cool concept. It's sensor fusion.
Sensor fusion is the idea that to measure something that you care about, measure lots and lots of stuff, and then use all that information to measure the thing you actually care about. So for example, my dad wears a watch, and the watch sends me an email when he falls down, but it doesn't send me an email when he sits down. And part of the reason is because there's an accelerometer on his watch. It measures the acceleration of the watch. But it turns out that's not actually how it works, because the accelerometer on there is terrible. It's a little $30 chip. It's a piece of junk. The reason that the thing doesn't send me an email when he sits down, only when he falls, is because it's also got a Wi-Fi chip, a GPS chip, a Bluetooth chip, all sorts of other tools in there that are measuring lots of things. And the correlation of all that information lets it tell the difference between when he sat down and when he fell. And that's incredibly powerful. We do the same thing in the ocean. We measure lots of different chemical parameters and use that to understand more precisely than any one measurement could, what is the alkalinity of the water? What is the carbon content of the ocean?
I think you published something on LinkedIn. You just recently has a breakthrough because everyone has this question about how you can precisely measure carbon removal in the ocean. I have very basic understanding about carbon removal in the ocean. I want to ask, does it work for all different pathways in the ocean, or it works specifically for certain type of pathways?
That's a great question. So the tool that we've built is a sensor that measures the alkalinity in the water. It's sort of the ability of the water to buffer acid. And traditionally, the way you measure this is by going into the laboratory, taking a sample of the water, and using complex equipment and a skilled chemist to titrate a little bit of acid into the thing and make precise measurements. It's very, very powerful, very expensive. The problem is analytic chemists don't scale. Laboratories don't scale. If you want to talk about billions of tons of carbon, you need to sense things that in ways that don't involve laboratories or humans. And so we've developed a system that doesn't involve laboratories or humans. It's all on chip to measure alkalinity in the ocean. And what that alkalinity measurement lets you do is great for alkalinity enhancement, for example, but it also lets you probe the total carbon in the water and the CO2 dissolved in the water, along with a measurement of pH. So we can actually probe many different kinds and do monitoring for many different kinds of carbon sequestration in the ocean using the suite of tools we're building, which is the reason that we're focused on sensor fusion.
How big is the tool?
It's tiny. It's a little tiny thing. Yeah, the part that's actually doing the work is a little chip. And then we've worked really hard to build the rest of the system in ways that scale, both in fabrication, but that are small and easy to deploy. So the current system that we built fits in the palm of my hand, and the part that's actually doing all the heavy lifting is smaller than my fingernail. As we grow and as we build more and more of these, we're going to make them smaller and more deployable. But right now they're already hand size, so they're pretty tiny.
And then do you work with ocean alkalinity enhancement companies?
Yeah, we're starting to work with ocean alkalinity enhancement companies and go out and put pilots in their projects.
Okay, yeah, so it's like a enabling tech. That's cool. Ideally, you produce these kind of very small device and you just sell it to them. Then they can deploy the way that they on their.
Exactly. Yeah. We're trying to eliminate as much as possible the humans from the loop. Not because we don't like humans, we love humans. There aren't enough chemists in the world to do the work.
Exactly.
So we're trying to make it as easy as possible to get the measurements done.
The sensors, they send out real-time data back to yours.
So it sort of depends on details. We've designed the system so that the sensors send out data in real time, a rich data stream. And ideally, when we get telemetry home, we can see the data, QC the data, and keep track of everything like calibration and the history of that sensor in real time so that we can provide people with a real-time picture of what's happening in their system.
Is it similar to Internet of Things?
Yeah, it has very much an Internet of Things flavor. It's very much an Internet of Things kind of idea where there are sensors that are out there in the world and they're sending data home. The ocean is a brutal place to work. It wants to break your toys and steal your money and send you home crying. It's a very brutal place to work. And so the complications of working in the ocean make it a slightly more thorny problem than traditional Internet of Things. You have to deal with the ocean and its cruelties. But yeah, but it's largely that.
Okay, now I get it. So you have a sensor that you have all the sensors, you put them all the sensors together, it gets the information and data from the ocean that you need to know exactly how the carbon is sequestered in the ocean or the carbon is removed in the ocean. You remove the human actions as much as possible so then it's low cost and scalable.
Yeah, exactly. The way I think about this is a company that sequesters carbon in the ocean is making gold, right? It's a carbon offset. It's an asset that they can sell. The problem is that gold is invisible, right?
Yes.
You look at the water, you can't see it. And so our job is to make that gold visible. And that's a necessary thing for the market to function, that the buyers can see exactly what happened and know when and where the carbon went in, right? And so that's our job. Our job is to enable that, to make that gold visible.
Awesome. Okay, now we'll move to the fun part.
How would you explain this to an 8-year-old?
Okay, I love this. So sensor fusion for an 8-year-old. Imagine you've got a Marvel superhero, right? And they have some amazing thing. They can see through walls, but maybe they can't hear anything. You get one superhero and they can sense amazing things, but you get a team of superheroes together and they have a much richer picture of everything that's going on. They can see what's on the other side of the wall. They can also feel what's on the other side of the wall and hear what's on the other side of the wall. And that kind of having lots of superpowers is more than just having one. And that's what sensor fusion is all about.
You can also put all the superhero in a tiny space.
Exactly. That's our device in the ocean is a bunch of Marvel superheroes measuring carbon in the ocean. That's exactly right. It's a whole team.
Yeah, that's the smoothest 8-year-old explanation ever happened in this.
Fantastic. We're putting it on our marketing equipment now.
And so then the next session is you answer a question from a previous guest. His question is what methods and what tools would be better for us here at U to communicate with our allies in climate tech?
That's such an interesting question. One of the frustrations that I have in climate tech is that a lot of our most important, most valuable allies are folks in the conservation world. And there's a huge disconnect between the traditional notion of environmentalism, we should be taking our hands off the system, right? We should just remove ourselves from nature. And the climate tech world, where we're looking at it and saying, we've got to control the levers and make this better because we've been accidentally controlling the climate without paying attention for centuries. We need to do this more intentionally. And I think a huge communication problem is that those two communities should be allies. And right now they're often not. And I really wish we could solve that problem. That one really pains me.
Yeah, exactly. I feel like those two are not talking to each other. Hopefully this conversation can spark more conversations in a broader scale from here.
I hope so.
Will you leave a question for the next guest?
Yeah, there's so many questions. What scares you about climate tech and where we are right now? And what gives you hope?
Great
I think about those a lot because a lot of things scare me. And I try to hold on to the bits of hope that are out there. And I think there are a lot. So I'd be curious to hear what the next guest has to say.
Yeah, I have those questions in my head all the time. But I think the more I talk to people like you, I'm more hopeful. I do feel like, and I believe that humanity always wins. So hopefully we can get there.
We'll do it together. It's a team effort.
The next question is, why did you decide to work in climate?
Well, I was very happy as a professor of theoretical physics. And then I had a kid. And all of a sudden it mattered to me that the world was sort of burning down around us. It meant something sort of tangible to me in my child that hadn't resonated with me before. And all of a sudden I was like, I've got to do something about this. So I left physics, moved into oceanography, and then eventually into climate tech. And I got so frustrated with the tools not being there for the kinds of problems that I care about, carbon sequestration, that I quit and left the university and started Aquatic Labs. But really, at the end of the day, it's because I had kids and it changed how I viewed my responsibilities.
Yeah, how old is your kid right now?
That one's 11. My other child just turned 10.
Okay.
They keep
So
me
it's
going.
you've both worked in the best universities in the US, Harvard and MIT. You work as a professor of physics. I would love to think people who work in the top universities for research and academic in physics will be able to change the world in the climate space, or is it not fast
Well,
enough?
I'll tell you, it has been having a background in physics has been really useful in the sense that, look, if you get a PhD in chemistry, if you get a good education in biology, if you get a good education in physics, the real education is not a list of facts in biology or a list of facts in physics. It's not being scared of really hard problems and being willing to do the hard work to figure it out. Whatever your field is, that's the power of a great education. And I think bringing that from physics into a field that I wasn't an expert in, oceanography, I came in not scared, but very much aware of the hard work that was required. And so I think that's a really important part of the story. I think that whether it's physics or biology or wherever you're coming from, coming into a new set of questions with willingness to do the hard work, is really critical and really important. And that's the gift that a good education gives you.
Yeah, I'm so glad that people like yourself decided to come and work in climate. I will want to do something new for season 4. If you can leave one sentence of hope.
One sentence of hope. Oh, I like that.
Yes.
Okay, I'll tell you the thing that makes me most hopeful right now. We've built some really cool technology and that's great, but the thing that we've really built is a team of people who care deeply and are incredibly passionate about making things better. And I walk into the lab every day and it gives me hope just seeing what these folks are doing. It's so much fun. And that I think is what I see is companies and research groups all over the world just really dedicated and driven. The harder things are, the more people buckle down. So that's what gives me hope is my team.
Yeah, sharing stories like this also gives me hope. Thank you so much. This is fun. This is so good.
Thank you, Lydia. That was really a pleasure. Thanks so much for running this podcast. This is great.